Let A, B, C be positive real numbers with the product of A, B, C being 1. Then show that the following inequality holds true. Now let's move on to the solution. We have that since A, B, C are all positive real numbers, we can find another three positive real numbers x, y, and z such that A equals x by y, B equals y by z, and since ABC equals 1, we get that C equals 1 by AB, which equals 1 by x by y times y by z, which is nothing but z by x. Plugging these back into the inequality, we get that a minus 1 plus 1 by b equals x by y minus 1 plus z by y, which equals x minus y plus z whole over y. Similarly, for the other two terms, we get the following results. So now we just have to show that minus y plus z by y, y minus z plus x by z, z minus x plus y by x is less than or equal to 1. Now we multiply with xyz on both sides to get the following. The sum of p and q is x minus y plus z plus y minus z plus x, which is nothing but 2x, which implies that x is the arithmetic mean of p and q. Similarly, we get that y is the arithmetic mean of q and r, and z is the arithmetic mean of r and p. Now we rewrite the previous inequality as such. P times q times r is less than or equal to the product of the arithmetic means of p, q, and r taken two at a time. Now we can multiply by 8 on both sides to get that 8pqr is less than or equal to p plus q times q plus r times r plus p. As this inequality will lead to the original problem with some simple substitutions, that is going in the reverse way of what we did, our job is done if we can show that this previous inequality is true. We will now remark that every square of a real number is non-negative. That is, if a is a real number, then a square is non-negative. So if we let a be root p minus root q, then we have that root p minus root q whole square is greater than or equal to 0. Expanding, we get that p minus 2 root pq plus q is greater than or equal to 0. We can add 2 root pq on both sides to get that p plus q is greater than or equal to 2 root pq. Similarly, we also get that q plus r is greater than or equal to 2 root qr, and r plus p is greater than or equal to 2 root rp. Multiplying all the three previous inequalities, we get that p plus q times q plus r times r plus q is greater than or equal to 2 root pq times 2 root qr times 2 root rp, which is nothing but 8pqr. Notice that this is the exact same inequality which we previously wanted to prove. Hence, we have shown that the original inequality holds true. Thank you for watching and try this IMO problem if you can.